So exercise 10 is the last one here, and if you look at this, I'm guessing the left side is going to be the one to start working with. So what I'm going to do is, I see I've got two different fractions here with different denominators. So I'm going to go ahead and get a common denominator. I'm going to write this out. You wouldn't do this part. I mean, you'd still write down your solution, but you wouldn't have to write down this exact step. So I'm going to go like this. So what I've done, let's just point this out. This guy right here is here, and this guy right here is here. What's new is this guy and this guy, but I'm multiplying by the same thing, so it's like multiplying by 1. So what do we have? Here, we've got 1 plus the sine squared. I'm going to draw this out a little bit more. Now minus over here, we've got 1 minus the sine squared. And that's over 1 plus sine times 1 minus sine. Okay, now, be careful. You can't just distribute this 2 in. Okay, you actually have to do the foiling. So, what are we going to do here? Well, let's go ahead. Let me see here. How do I want to work this? Well, I know that I want to get tangent and secant, and I need to get 4 of them over there. So I guess, let's go ahead and try multiplying these numerators out and see if anything cancels here. So this guy right here is 1. So 1 plus 2 sine theta plus sine squared theta. That's what happens if you FOIL this guy out. You get this. Minus, so I got that guy. Minus, let's multiply this guy out. So forget about this right here. We'll just do this. This is 1 minus 2 sine theta plus sine squared theta. And now that whole thing is still over this guy right here, which is 1 plus sine theta, 1 minus sine theta, like that. Okay, so now let's distribute this negative in to the numerator so that I can start dropping these parentheses. So minus 1 plus 2 sine theta minus sine squared theta, and that is still over our denominator, like that. Okay, so let's see here. The 1's cancel out. The sine squareds cancel out. And on the numerator, I'm left with 4 sine theta. Okay, so that's fairly reassuring. I'll tell you why here. If you look back up, what we want to get is 4 times this guy. So I needed a 4 in there, and I just got my 4. Okay, hopefully the rest of this reduces out nice. So the next step would be to take this bottom, and let's go ahead and multiply that together. And the reason that I typically don't do it to start with is because usually things cancel, but in this case they didn't. So I'm not multiplying things together really until I have no other options. So 1 times 1 is 1. Okay, it's going to be a plus sign minus sign, so those are going to drop out. So minus sine squared theta. Let's just write it without the parentheses. It's more proper to write it with the parentheses in there, but a lot of people don't, because it's still function notation. But we'll forego that. In fact, some people don't even write the thetas in there. The thetas are called they're the arguments, but people don't put them in there a lot of times just because it becomes more messy. So 1 minus sine squared. Hopefully you realize that that's equal to cosine squared. And so when we move cosine squared, well, what we can do this. So before moving cosine squared up, what I'm going to do is this. I'm going to go 4 sine theta over cosine theta times 1 over cosine theta. So basically I split this guy up into two pieces. So sine over cosine, and the reason I did that is because look, I know I needed to get a tangent, and I saw a sine on top, so I needed to get those guys together. So I've still got 4. Sine over cosine is tangent, so there's my tangent, and 1 over cosine is secant. And that's what we wanted to get.